All right, so moving right along, we have a fully functioning network now. We have DHCP running down here on our R&D router. We have routing protocols distributing the routes to all three routers. The last thing we need to do is actually get our client connected to the internet. Yes, the internet is all in one computer. Didn't you know that? It's all in one big computer. So basically, to connect this client to the internet computer, we will have to configure network address translation and port address translation here on the HQ router. And like we did with DHCP, we're going to set up NAT through the command line, just so you can see what all's involved without clicking the little buttons in the useless little Java application. So without further ado, let's hop right into this. So we'll go to the HQ router. And first off, I'm pretty sure we verified this earlier, but let's verify again that we can actually ping this internet box from our HQ router. So we'll do show IP interface brief. And it is on the 172.18.4 network, and I know I gave this the .10 address, so we'll do ping 172.18.4.10, and we can ping the internet from the HQ router. Now, just as further verification to prove I've got nothing up my sleeve, let's go here to this guy, and let's do ping 172.18.4.10, and it gets all the way up to 12.1, and says, hey, the destination host is unreachable. I don't have a route to get to that guy. And that is honestly by design. If we had routing fully configured, we'd have a default route for everything to go up to the HQ. And since HQ knows about that 172.18 network, it would try to go out and send the traffic out to the internet. The internet wouldn't know how to get the traffic back, so it would still fail. It's just it would fail up at the HQ router instead of the R&D router. As part of our NAT configuration, we will configure a static route for the sales and the R&D locations so that they can get all of their unknown traffic up to the HQ and be NATed out to the internet. So let's go configure NAT. We'll go into configuration mode, and the first thing we have to do is tell the router which interface is the inside and which interface is the outside. Now, I still have this show IP interface brief, so we know that interface Fast Ethernet 00 is the outside and everything else is an inside interface. Now again, normally if we were truly breaking this out on an actual corporate network, we would probably have another router whose sole purpose is to have an outside interface and an inside interface, so you're not having to go manually set inside interfaces on all of these other interfaces. However, I just didn't set the lab up that way, just in the hope and the idea of keeping it simple, because simpler is always better, especially at the CCENT level. If you continue on with the CCNA, in the next course, the follow-on course for this, the ICND2, we'll actually have a pretty complex lab where we look at all of the configuration options available to you, including frame relay and NAT and all kinds of nice stuff. But that's then, this is now. So we'll go into interface Fast Ethernet 0/0, and we'll do IP NAT, and the options we have are inside and outside. So we'll do NAT outside, and then we'll do interface serial 0/0, IP NAT inside, switch over to serial 01 and do IP NAT inside, and I'll do the loopback interface as well just to be consistent. So we'll do interface LO10 and IP NAT inside on that guy as well. So that's all of the interface level configuration. We're going to go back out to the global config mode, and now we're going to configure our NAT pool. Now, for our purposes, we're only going to use the single IP address that is the outside interface. If we needed to, or if we so desired, we could set up an entire pool of addresses and tell the router, use this pool of addresses and assign each host to its own IP address, and when you run out of addresses in the NAT pool, no one else can go through this NAT. Or we could tell it, use this pool of addresses, but allow more than one address per outside address. So we'll configure the one outside address. So we're going to do IP NAT pool. We're going to have to give the pool a name, so we'll say NAT pool. We're going to specify the start IP address. In this case, it is 172.18.4.1, so 172.18.4.1. And the end IP address, which is 172.18.4.1. And lastly, we have to specify a prefix length, or a net mask. Now, you've defined the start and stop addresses already in the pool definition. This prefix length is just, I guess, kind of a second sanity check. If you have multiple addresses in your NAT pool, let's say you specify an entire Class C network here. We do 172.18.4.1, 172.18.4.254. and we specify a /27 prefix length, then the router will say, well, that pool doesn't fit that net mask, and so I'm going to reject it. In this case, our outside interface is a /24. It's an entire Class C network. So we'll do prefix length 24, and we can optionally specify a type, match host, keep the numbers the same after translation, or have a rotary address pool. Since there's only one address on this pool, there's no point in specifying a type, so we'll just hit enter. So at this point, we're about halfway through the configuration. We'll pause here. We'll pick up in the next video.